Hello and welcome to Quadratic Maximum and Minimum Word Problems Part 2. We're going to do example number 1. A model rocket is shot straight up from the roof of a school. The height h in meters relative to the ground at any time t seconds is approximated by the model h equals 15 minus 5t squared plus 23t. And before you even read the next few part A, B, and C, I noticed that there's something wrong with the equation as listed there. Normally, um, a parabola or a quadratic is listed in standard form. This is in standard form. Is written in descending order. And by descending order, I'm referring to the exponent. And so the exponent right here, the first exponent should be the highest exponent right here, so it's descending. So it should be rewritten so that it's minus 5t squared plus 23t plus 15. And then now it's written in descending order with the high exponent of t first, which is an exponent of 2, and then the next term is an exponent of 1, and the last term has no exponent. So let's read part A. What is the height of the school? Wow, there's a situation here, and this apparent relation here represents the height of this rocket at any time. It's the height of the rocket, but they're asking us for the height of the school. So you have to make the realization that the rocket is at the height of the school at the beginning of time, when this time is measured, so when time was 0. Okay, so you have to make that realization. That's very important. So this is when t equals 0. You have to be able to translate this from the context of the situation to a mathematical concept, time of 0. Okay, and so we can do that right away. H equals negative 5t squared plus 23t plus 15, and we substitute t for 0. So I'm going to put this in red. 0 squared, I'm going to put a 0 here, plus 23 times 0, I replace t for 0 here, plus 15, and h equals 15. Now you might be wondering, Mr. Shin, you shouldn't have been doing this. There's another faster way of doing this. If you remember, I'm going to write the actual standard form here, ax squared plus bx plus c, and write the general form for it with y and x. If you guys remember, this little shortcut, the c value, which is the last term in standard form, represents the y-intercept. So this represents the y-intercept, or in this case, this represents the the h-intercept, which is the initial height. Now, if I were to do this, answer this question graphically, so this is height in meters and time in seconds. This represents that y-intercept or that c-intercept, that 15 there. So it's going to start at 15, which represents a time of 0. And there, this is another way of answering this question using the graph, connecting the y-intercept to the height of the school. So there's two ways of answering this question. Using the algebraic version, understanding that when time is 0, that is the initial height of the rocket, which matches the height of the school. Or you can give me the graphical version, where the height of the rocket starts at 15, using this definition of the y-intercept. So you can extract it right off the bat in one snap. You don't have to do this right away. Okay? Now, this is the sort of thing that I need you guys to do for your portfolio, where you need to show off your wealth of knowledge, answering questions in multiple ways, making connections between two different concepts here, either T0 or picking things out using the definition of the standard form. Okay. Part B. How long does a rocket stay above 10 meters? So we have this. I'm going to continue drawing this. So this is my rocket. We know that this is a parabola with A that's opening down because of that A value that's negative. So it's opening down and it's going to go up. And we know this from the context of the situation. This is how a rocket is shot up in the air, as we said at the very beginning of the unit, that anytime, well, the quadratics measure gravity. So we can just assume that's going to be a parabola. So they want to know how long does this stay above 10 meters. So I'm going to say about 10 meters is about here. And apparently, this rocket will, at some point, get below 10 meters and then hit the ground. So we need to find the time at which it is 10 meters. we need to find an associated time. So this is going to be part B here. Apparently, the height is 10 meters. We want to know the time. What is the time at 10 meters? Okay. So I'm going to write up the equation because the equation tells us, relates the height and time. So I'm going to replace h with 10. So I'm going to copy out the equation. So this is negative 5t squared plus 23t plus 15. And here we have a quadratic. It's basically asking us, when is this quadratic equaling to 10? When does this quadratic have an h value of 10? And so we can't solve this equation as it is right now. We can either solve it by factoring or solving by quadratic formula. And this question, when is this parabola equaling to 10, is a very difficult question to answer. But what we do know is how to answer this question, is when is a different parabola, so if I move that 10 to the other side, so I'm going to subtract both sides by 10, so 15 minus 10 will be 5. We can answer this question, when is this parabola here equaling to? So this equation here is a very difficult question to answer. It's asking for when is this parabola equaling to 10. I can't do that unless I use a graphing calculator like Desmos. But we can transform this into an easier question by moving the 10 to the other side. So if I move the 10 to the other side and subtracting both sides by 10, so minus 5t squared plus 23t, 15 minus 10 will be 5. This is a new question. It's asking when is this new parabola equaling to 0. This is asking, we have the tools for this because we can find out the x, this is asking for the t-intercepts or x-intercepts of this parabola. What tools do we have? We have factoring or quadratic formula. Okay, so this question we don't have tools for. This question we do. This question, when we solve for this, this is the root of this equation. When we solve for this, this is the x-intercepts or the t-intercepts of this new parabola, but that's not the question they're asking for. They're asking for the original one. Okay. All right, so now we have a quadratic that equals to 0. We have two choices, quadratic formula or factoring. I know that I can't factor it. We could try, but I know we can't, so we're going to have to use the other one, which is the quadratic formula. And a lot of you guys forget to write this part of the quadratic formula, which is the t-intercepts equal to negative b plus minus b squared minus 4ac all over 2a. And we know that this is going to be the a value, this is the p, b, and this is the c. So b is going to be 23, so add the 23 in brackets there. Put the 23 in brackets here, 23 squared minus 4a is negative 5, and c is positive 5. Extend the square root sign because it's too short. And 2 times a, which is going to be 2 times negative 5. And now we're going to use our calculator. Okay. Negative 23 plus minus. Underneath here is just going to be negative 10. And I'm going to do all this in the calculator, so that's going to be 23 squared plus 20 times 5, which is going to be 100. So that's 629. Square root that. And we have 25.0798 ... and I'm going to keep that value on the calculator to get the most accurate answer. And now I'm going to give two answers, the positive and negative version. Alright, so we're going to now plug this in our calculator. So negative 23 plus 25.07 divided by negative 10, and that's going to be negative 0.207 ... I haven't rounded it yet. ... means I'm keeping all the decimals. And I'm going to try this again. Negative 23 with the minus 25 this time. Divided by negative 10. And that is 4.807 ... And does it say to round it to anything? Okay, so now we're going to round it. It doesn't say to the nearest tenth or anything, so we can round it to whatever we want. I'm going to round it to the nearest tenth. And again, if I'm rounding, I have to tell them that this value of t, this is the times that we're solving here. This is the exact value, exact value, exact value, exact value with the dot, dot, dots. Now I'm stating that it's going to be an approximate value. So this is not equal to this, it's only approximately equal to that. So I have one t value, one t-intercept, that's approximately negative 0.21. I'm also going to have another t-intercept that's approximately 4.81. I'm choosing to go with the hundredths. And so there's an actual unit to t, which is seconds. So let's try to interpret these two values here on the graph. What do these t values mean? These t values are, when does this parabola equal to 10? So this parabola equals to 10. Okay, I'm going to extend this parabola backwards in time here in a different color because it doesn't exist. And 10 is at this time. So at this time, it's going to be negative 0.21 seconds. What this means is if this rocket was fired from 10 meters, then it would have been launched 0.21 seconds beforehand, which didn't exist, but that's what mathematically modeling this means. Okay, the math doesn't understand the situation it's in. It's up to us as humans to interpret what this means, and that's what that means. It doesn't make sense, so I'm just going to leave it out for now. Or I can say reject, because it doesn't make sense according to the context of the situation. Now, they gave us a second time at which the height was 10. So that's this time right here. Boom. T is equal to 4.81 seconds approximately. So approximately 4.81 seconds, that's the height of the rocket. The height of the rocket was 10 meters at t equals 4.18 seconds. So we can answer this question, part B now. How long does this rocket stay above 10 meters? Well, from 0 to this time, that's how long it stayed above 10 meters. So let's conclude. Therefore, the height of rocket stayed above 10 meters for 4.81 seconds. All right, part C. What is the maximum height of this rocket, and when does it occur? So when they say the maximum height of the rocket, you have to ask yourself what part of the parabola is that looking for. And in this case, it's looking for the highest part here, which is the vertex. Okay, so they're looking for the vertex. They want to know what is that maximum height, which is right there, which is the y-coordinate of the vertex, and they're asking for when does this occur, which happens to be the t-intercept, or not the t-value, the average t-value between these two symmetrical points here. Okay, so part C, we can do it by completing the square to find the vertex, or we can average these two symmetrical points on the parabola. Notice I'm not calling them t-intercepts because that's not where it hits the t-axis, but it still works because these are two symmetrical parts of the parabola, and in the middle would be the axis of symmetry. Okay, so we have two options. Tool 1 is to average out the roots. These are not x-intercepts because it doesn't hit the x-axis or the t-axis. These are just parts, answers to this question. These are roots. So average out the roots to find axis of symmetry. And our second tool is complete the square to change it to vertex form. Now, since we just recently learned about completing the square, I'm going to do that right now. So I'm going to use tool number 2, even though it's a little bit more difficult, but we need to practice doing that. And again, for your portfolio, you need to demonstrate your wealth of knowledge. Okay, so with this, I'm going to remember the very first thing to converting this to vertex form from standard form is to extract the a value out. So I'm going to factor out -5 from only the first two terms. And now, because this is a word problem, we can we don't have to use fractions. We can use decimals because the answer is going to be height and time, which is a measured value, so we can have decimal values. So we're going to divide out -5. So 23 divided by -5 would be -4.6 t plus 15. So after that, we have to half this value and square it in order to make it a perfect square trinomial. So we have to half it. I'm going to put it over here. 4.6, take that b value, divide it by 2, and square it. So half of 4.6 is 2.3, and then we square it. So 2.3 squared will be 5.29. But I'm going to highlight this one because this is the important value that will show up at the end. Okay, so 5.29 is what we're going to be adding and subtracting in order to create a perfect square trinomial. Plus 5.29 minus 5.29, close that bracket, plus 15. Let me highlight this. 5.29 and -5.29 come from here. Okay, now we don't have a trinomial here. We need to get rid of that last term, so we're going to multiply -5 times -5.29. So, and we're only going to multiply the last one. So we distribute only that one term. So -5 times -5.29 will be positive 26.45. 26.45 plus 15. And now that we have this perfect square trinomial, we need to find two numbers that'll multiply to 5.29, which is 2.3, and two numbers that add to 4.6, which is 2.3 again, which is that yellow. This is a very important number. So right here, it's going to be t minus 2.3 all squared. And then we're going to simplify the last two terms here. 26.45 plus 15 will be 41. 41.45. And so now we can actually extract the x-intercept. No, not the x-intercept. We can extract the x value and the y value of the vertex. So in this case, the t and the time and height of the highest value of the rocket. Okay, so this represents the x value of the vertex. So that's going to be 2.3. And this represents the y value of the vertex, which is 41.45. We're going to write this as a coordinate here. Highlight this. This is the blue part. And this is the coordinate of that. So now we can answer this question. When does this rocket hit the maximum height? At 2.3 seconds. And what is the maximum height? Which is 41.45, that y value or h value right there. So max height, the max height is 41.45 meters and occurs 2.3 seconds after being launched. Okay, and that's it. If you have any questions, please see me on the Google chat or email me. Good luck.